Students, this is the Unit 4 preview video and notes. By far the most important preview video of the entire year. This is introduction to a concept called SOH CAH TOA. SOH CAH TOA. You should have your preview notes handy. You also need a scientific calculator handy. And you also want to have this reference card in front of you. Please make note of the location that you are watching this video, as well as the date and time, and you will need a parent signature sign off that you watched it yourself. Let's do a quick review here. You're going to look at the following diagrams and order the sides from least to greatest on the left and order the angles from least to greatest on the right. You should be able to explain why you ordered the way you did. Go ahead and order those. I'll give you 1 minute. All right, let's take a look and see what you did. This is the smallest angle, so of course that is going to be the shortest side. So you should have FE or EF, it doesn't matter in this case, as the smallest side. Then here is the medium angle, therefore this would be the medium side, so FD or DF, doesn't matter. And then here we have the largest angle, therefore this is the longest side. So D to E. Over on the right, we start with the shortest side and we work ourselves backwards to the smallest angle, which is angle X. And then the medium side, which is 11, down to the medium angle, which is going to be angle Y. And then the longest side goes towards the largest angle, which is angle Z. So we see that the sides and angles of triangles are somehow interconnected to each other. The longer the side, the larger the angle. We're going to be introducing a concept called SOH CAH TOA today. And it's going to be related specifically to right triangles only, the relationships of angles and sides. The vocabulary word you need is trigonometry, sine ratio, cosine ratio, tangent ratio, the acronym SOH CAH TOA, and you need to know what a scientific calculator looks like. Students, you need, required, absolutely required, you must have a scientific calculator. The one I recommend that's cheap is the TI-30. I think it's usually called XA, or A is fine. The more expensive one, but also good for the rest of the years at Valley, would be the TI 83 or 84, but the 84 Silver Plus, but the non-color. Do not get a color calculator. You must have that for this section, one or the other. A TI-30XA or a TI-84 recommended Silver Plus if you want. That's good for the rest of the year at Valley, rest of your years at Valley. What have we learned so far? What we figured out so far is that there is a relationship between sides and angles and triangles. The larger, and not longer, excuse me, the larger the angle, the longer the side. The opposite side. And the smaller the angle, then the shorter the opposite side. So there is an interrelationship between sides and angles in triangles. Today we're going to study an additional relationship of sides and angles, but and triangle angles, but it's going to be specifically in right triangles only. Specifically called right triangles only. The study of right triangles and everything related to right triangles is called trigonometry. So what you're actually learning today is the introduction to trigonometry. Very simplistic, very basic. So let's start with the most basic concept. To work with right triangles, you must be able to easily spot the hypotenuse. The hypotenuse is the longest side in a right triangle, and it's across from the right angle. The easiest way to find it, trace the right angle, physically trace pick up your pencil and physically trace the right angle. Now draw a little arrow across from that right angle. The side that is across the right angle is the longest side in a right triangle. That is the hypotenuse. I'm going to use the abbreviation hypo. It is absolutely critical. You can quickly and easily spot the hypo in any right triangle. So what I'd like you to do here is I'd like you to retrace the right angle and find the hypotenuse in the following triangles. Go. Okay, let's see how you did. Here's your right angle. That would make 10 the hypotenuse. Here's your right angle here. That would make this side 6 your hypotenuse. Here's your right angle. That would make 5, in this case, your hypotenuse. And there's your right angle here, so that would make 10 the hypo. It's very critical you're able to identify the hypotenuse in any right triangle. Go back, review this as you need to. To study the relationship of side lengths and angle measures in right triangles, you must first label a right triangle with the terms hypotenuse, opposite, and adjacent. We're going to use the symbol theta to represent a missing or an unknown angle. Let me fill that in for you once again. To study the relationship of side lengths and angle measures in a right triangle, you must first learn to label. Very critical that you must get in the habit of labeling a right triangle with these 3 terms: a hypotenuse, the opposite side, and the adjacent side. We're going to be using this symbol that's called theta to represent a missing angle. Just like you use X to represent a missing number, in trigonometry, we use that symbol specifically for angles. For example, in this right triangle, the first thing you want to find is the hypo. So there's your right angle. The right angle points to the hypo. So trace it and write the word hypo. Now, trace the angle theta. Sweep it. Sweep it. Physically sweep it. Put your pencil on the paper and sweep that angle. Now, from that angle, draw an arrow to the opposite side. That, to that angle theta, is the opposite side. Then draw an arrow to the side that's right next to theta, right next to, that's why we call that adjacent. Adjacent means next to. That is the adjacent side. You take a moment, and right here, I'd like you to try to label the hypo, the opposite, and adjacent in that given diagram. Go. Let's see how you did. First off, you always sweep the angle that you're working with. That one angle right there. We darken our right angle. That identifies our hypo. Then we go to our angle, unknown angle theta. We sweep it, and then we go across or opposite. This would be the opposite side. And then right next to it, but not the hypo, that would be the adjacent side. The rest of the lesson will not make any sense unless you're able to do this accurately, so I'd like you to try this again on your own. I'm going to pause here. I'd like you to, once again, sweep the given angle, find the hypotenuse, the opposite side, and the adjacent side in this diagram. Go. Okay, let's see how you did. First up, there's your right angle, so that forces this to be the hypotenuse. Next, you sweep the angle that you're working with, which in this case is angle 32. And we go across from 32. That is going to be our opposite side. Then we go next to 32, and that is going to be our adjacent side. So your opposite and adjacent is determined on what angle you're working with. I'm going to give you 1 minute, and I'd like you to go through and again sweep the angle that you're working with, find the opposite, the adjacent, and the hypo in these diagrams. Okay, let's see how you did. So in this diagram, let's start by labeling the hypo. So there's your right angle. That makes this 24, the hypotenuse. And here is your right angle. That makes this the hypotenuse. Now in this diagram, we sweep the 54. The side that's opposite the 54, that's going to be your opposite side. And the side that's next to the 54, that's going to be your adjacent side. Down here, we're working with 21, so we sweep the 21. And you go across, that's going to be your opposite side. and you go next to, and that is your adjacent side. If you need to, go back and review this, because you can't really move forward in this lesson until you're able to do this very accurately and consistently. Okay, now we're going to talk about ratio of the sides. The sides and angles are interrelated in a certain way, and we're going to be using ratios to express those relationships. So when I say ratio, remember ratio means something over something. So we're going to find the ratio of the sides by starting with angle A. So here's angle A. This is just an example. So now we label the opposite, the adjacent, and the hypo. So angle A, this is going to be our opposite side because it's across from the angle. This is our adjacent side. And then, of course, 5 is across from the right angle. That's our hypo. Okay, so now let's start making some ratios. There's 3 basic ratios you need to be comfortable with in working here. One is taking the ratio of the opposite side over the hypotenuse. So in this case, the opposite side would be 3, and the hypo would be 5. So then we do the ratio, 3 divided by 5. 3 divided by 5, and I'd like you to take this decimal to the 4th decimal place. So that's going to be 0.6000. That's one ratio, opposite over hypo. Can you write OH? That is one combination you need to be familiar with. Let's try a couple other combinations. Another combination I want you to be familiar with is adjacent over hypo, which in this demonstration is going to be 4 over 5. Adjacent AH. Let's go ahead and get that ratio into a decimal. 4 divided by 5, 0.8. The last ratio combination you need to be familiar with is the opposite over the adjacent. So opposite, which is 3 in this case, over the adjacent, which is 4. 3/4 of a dollar, you should know. That's opposite over adjacent. So these are 3 different relational ratios in a right triangle. And the ratios are opposite over hypo, adjacent over hypo, and opposite over adjacent. Those ratios have specific names. Those specific ratios have specific names. The opposite over hypo ratio is called sine. Sine, called the sine ratio. Add an S there. The adjacent over hypo ratio is called cosine. Put a C there. And the opposite over adjacent is called the tangent. Put a T. So to redefine, sine ratio equals opposite over hypo, cosine ratio equals adjacent over hypo, and tangent ratio equals opposite over adjacent. This is where we get the acronym SOH CAH TOA. The sine ratio of an angle equals opposite over hypo, cosine ratio of an angle equals adjacent over hypo, and the tangent ratio of an angle equals opposite over adjacent. SOH CAH TOA. Turn the page. I'd like you to take a few additional seconds and attempt to memorize the definition of sine, cosine, and tangent. All right, try not to look at the top of your paper. Go here, and I'd like you to fill out the definitions of the sine of an angle ratio, the cosine of an angle ratio, and the tangent of an angle ratio. See if you can't fill that out now from memory using the acronym SOH CAH TOA. Sine is opposite over hypotenuse. That's SOH. Cosine is adjacent over hypotenuse. That's CAH. Tangent is opposite over adjacent. That's where we get the acronym TOA. We're going to use this to go ahead and find additional ratios using a different triangle this time. Now watch very, very carefully. It says right here we want the tangent ratio of angle X. So the first thing you do is you sweep angle X, and now you label the opposite, adjacent, and hypo according to angle X. And for angle X, this is opposite. That would make 12 adjacent. And of course 20 is across from your right angle, so that's your hypo. So for the tangent ratio, tangent is going to be opposite over adjacent. Write that in the margin, just as a quick hint, opposite over adjacent. Or you can write it like this, tangent ratio equals opposite over adjacent, which is TOA. So in this case, our opposite is going to be 16. Our adjacent is going to be 12. So the tangent ratio in this triangle of x, the tangent ratio of x, is going to be 16 divided by 12. Take it to the fourth decimal place, 1.33 repeating. Okay, now we want the cosine ratio of angle x. Same angle, cosine, right? Cosine, it's CAH, so cosine is adjacent over hypo. So write CAH in the margin. So this case, adjacent is going to be 12, and our hypo is over 20. So you want to get your calculators out. We're going to do 12 divided by 20, and we get 0.6. Take it to the fourth decimal place. That would be the cosine ratio of angle x. Now watch very carefully. Now we want the sine ratio of y, but that's a typo. Warning. So fix this. The right angle is never going to be used as our chosen angle. Keep that in mind. That is a typo. I'd like you to first fix that. We're going to talk about angle Z here. So change those both to angle Z, please. So y, in this case, the right angle can never be used as your chosen angle. I'll explain why in class. So change those both to Z. Now, when we move the angle, we're changing what is considered opposite and adjacent. So if we're going to use angle Z here, erase this opposite and adjacent, or just cross it out, because now your hypo doesn't change. Because now, if we're going to use Z, 12 is now the opposite, and 16 is the adjacent. So the opposite and adjacent can move around depending on the angle you're working with. So the sine ratio of angle Z, sine, put this in the margin, is sine is going to be the opposite over the hypotenuse. It's so. So the sine of angle Z, the opposite is going to be 12, and the hypo is going to be 20. So I do 12 divided by 20. And you get 0.6. Notice the cosine of angle X and the sine of angle Z are the same thing. Last one, we're going to do the cosine of angle Z. So write out the cosine ratio, which is CAH. Cosine is adjacent over hypo. And in this case, our adjacent side is going to be 16, and our hypo is going to be 20. So our ratio is going to be 16 divided by 20, and we get 0.8. Okay, very, very important that you're able to spot these ratios and correctly mark them. So go to page 8, please. And I'd like you to finish page 8. First, start by sweeping the angle. For example, if we went tangent angle A, start by sweeping A, label the opposite, adjacent, and hypo, and find the ratio. You have 1 minute to do all three. Okay, let's see how you did here. So if we want the tangent of angle A, we want, that's going to be TOA. So we label from angle A, our opposite is going to be 8, and our adjacent is going to be 15. So our opposite is 8 over our adjacent, which is 15. Then we do 8 divided by 15, and we get 0.533 repeating. That's called the tangent ratio. Sine is so it's SOH. So we want to find the sine of angle Z. So from angle Z, our opposite is going to be 12, and our hypo across from the right angle is going to be 37. So we're going to do opposite over hypo, so 12 over 37. 0.3243, round to the nearest fourth, 0.3243. That would be the sine ratio of angle Z. Now we're going to do the cosine ratio of angle Z here. Cosine is CAH, which is adjacent over hypo. So here, this would be our hypo, because it's across from the right angle. This would be our opposite, which would make 36 the adjacent. So our adjacent is 36, our hypo is 45. To find the ratio, you simply divide 36 divided by 45, and again we get 0.8. We can use these three ratios, sine, cosine, and tangent, to actually find missing angles and missing sides. Missing angles and missing sides. We're going to be following this part of your reference card. We use this technique only when we have right triangles. And the first thing you must do is whatever right triangle you're working with, you sweep the angle you're working with, and you label the opposite, the adjacent, and the hypo depending on the angle that you are working with. Now I'm going to show you how to use this technique to find a side of a right triangle. We're going to be using a technique called have, need, do. It says, find out what you have and what you need, then determine what you do. Say that out loud. Have, need, do. Again, say it out loud. Have, need, do. After you do have, need, do, you choose a proportion and solve for the unknown using sine, cosine, or tangent. Oh, there's the buzzword. You just did this. So once again, believe it or not, today's work is going to boil down yet again to another proportion, which you just completed an entire unit on. All right, we're going to take this very, very slow. Okay, we're going to start by labeling our given triangle. So we sweep the angle we're working with, which is 32, and we label opposite, adjacent, and hypo. Across from 32 is this. That's our opposite side, which is our unknown, so just write opposite. Right next to 32 is your adjacent, and then across from the right angle is your hypo. Very, very, very important that you label everything just like I did. Please do not trust your eyeballs. Physically trace, physically label all the sides. Now, in this case, we want to find X. We're going to limit ourselves to finding X. So you start by with what you have. We have the adjacent side. So I just write A for adjacent. We want, if we're going to solve for X, we want the opposite side. So we're going to put an O. Now the most important question you need to figure out is when do you use sine? When do we use the sine ratio? When do we use cosine? And when do we use tangent? How do you determine that? You look at the have and need combination. Look very carefully. We have an OA combination. So you ask yourself, what goes with OA? And you look over here on the right, and we find, this is also on your reference card, that opposite over adjacent, OA is tangent. the tangent ratio. So you want to write this ratio exactly as you see it. Do not plug anything in. Get in the habit of writing the ratio exactly as you see it, which is tangent of the angle theta over 1 equals the opposite side over the adjacent side. Okay, step 2. Now that you've done have, need, do, now we do circle, plug, chug. Very carefully, very slowly. Follow along with me. Tangent of theta. Well, our theta is 32 degrees. So we write it like this. Tangent, I'm going to just abbreviate tangent 32 degrees. Now put parentheses around that because it's not 32 degrees by itself. It's the tangent ratio of 32 degrees. Put parentheses around that, please. Over 1 equals circle opposite, circle physical, pick up your opposite, which is x, circle adjacent, come up here, circle the adjacent side, which is 15. Okay, 2 more steps. You do not touch a calculator until x is by itself. Are we clear? Okay, so our goal is to get x by itself. We're going to start by cross multiplying. Our next line reads like this. Parentheses, tangent 32 degrees. Remember, that's not 32, it's tan 32. Please keep parentheses around that. Times 15 equals 1 times x, which is basically x. Okay, x is by itself. Now the question is, how do you find the tangent ratio of 32 when you don't have any sides to work with? What's really amazing is your calculator has stored literally thousands and thousands of ratios based on several hundred years worth of experimentation inside that lovely little calculator of yours. I'm going to show you how to access those ratios. So we want to find the tangent ratio of angle 32. Now get out your calculator. Now pay attention because there's one of 2 ways to do this. Okay? If you have that TI 30, what you're going to do is in your calculator, you put 32, and then you're going to hit the, it's tangent, not sine, tangent of 32. You're going to hit the tangent ratio button, which is that one right there. So you do 32 tan. Now, if you have a TI 8384, you must first get it in degree mode. To get it in degree mode, there is a separate 2-minute video that has been loaded onto the website that you must watch to get it in degree mode. You're going to start by hitting mode there. Degree mode is default in the TI 30. Once you have it in degree mode, you're going to do, on your calculator, tan, then 32, and you're going to get the decimal. So this one's 32 tan. The other one is tan 32. Now, what should you be getting if you did this correctly? Look at my calculator here. My calculator goes 32 tan. So I do, and I'm in degree mode. See that little D-E-G-R-E-E-S? I'm in degree mode. So I go 32, and then I hit tangent. Wow, huge number. You need to take that number to the 4th decimal place, which is 0.6249. 0.6249. So this gets replaced with this decimal, 0.6249. Then we times by 15, and that's going to give us our missing side length, x. So on your calculator, I'm going to take that decimal. I'm going to times by 15. Now you round your final answer to the 10th place. In this case, it's going to be 9.4. So our final answer, x is 9.4. Now I know this looks completely and totally intimidating. Don't worry, you're going to get better at this with practice. Let's do another one together. Okay, now we're going to find y. So we're going to work with 32 again. You start by labeling, sweep that angle, put your pencil and sweep 32. Don't look at 32. I'd like you to physically sweep 32, please. Now, draw a little arrow going across 32. Trace that side, write the word opposite. Now go right next to the 32, trace that side, write the word adjacent. Darken over your right angle, and now identify your hypotenuse. Okay. Now, we're going for y this time. We have the adjacent side. Why do we have it? It's the only thing that we have a number on. So I just write A for adjacent. I need, because I want y now, I want the hypo. So again, the question is, what goes with AH? What goes with AH in our acronym SOH CAH TOA? Listen carefully. SOH CAH TOA. You should have heard that C there. So we're writing this ratio out right here. We're going to write cosine theta over 1 equals the adjacent side over hypo. Now we do circle, plug, chug. We're doing cosine. Theta is 32 degrees. Put 32 degrees and then put parentheses around that. Over 1 equals circle A, circle 15, put 15 there. Circle H, pick up Y, put Y there. Do not touch your calculator until your variable is by itself. Ready? We're going to get that by itself. So we cross multiply. Watch very carefully. I have cosine 32 degrees. Put parentheses around that. Times y equals 15 times 1, which is 15. You are not done. Y is not by itself. You want to get y by itself. So we have to divide by cosine 32 degrees. Keep parentheses around that. You're not getting rid of 32. You're getting rid of cosine 32. Okay, y is by itself now. So we have y equals 15 divided by whatever the cosine ratio of 32 degrees is. Now, to get cosine 32 in your calculators, on the TI-30, you put 32 and then cosine, and you get your decimal, take it to the 4th. After you get it into degree mode, in the TI-83, 84, you do cosine first, then 32, and you get your decimal. Let me show you what that decimal looks like. 32 degrees cosine. You should be getting 0.8480, 0.8480. So I put that where this is, 0.8480. And I have 15 divided by, not times. So to get my final answer, I do 15 divided by 0.8480 equals, you round it to the tenths place, which in this case is 17.7. All right. I want you to take a shot at these two on your own. I'm going to give you 5 minutes, and then I'll come back and explain it. Please do the best you can and go as far as you can on your own in the next 5 minutes. Do not just watch the video. Please try this on your own first. You have 5 minutes to do what you can. Okay, let's see how you did here. So in the first one, you should have started by labeling opposite, adjacent, and hypo depending on this angle. So we sweep that, and we go across, and that means that's our opposite side. That makes this our adjacent side, and then our right angle points to the hypo. So have, need, do. We have the hypo, so I put an H. I need, in this case, the adjacent side, so I put an A. You check out your card here and you ask yourself what goes with AH. That's what you're trying to figure out. What goes with adjacent and hypo. Hypo, adjacent, same thing, but we always place it adjacent before hypo. You look at this card and we see adjacent and hypo goes with CAH, which is cosine. So I write exactly this out, or you should have. We come here and rewrite cosine of the angle theta over 1 equals the adjacent over the hypo. Then you circle, plug, chug. Cosine theta, our theta is 18. So I'm going to come up here, rewrite cosine 18 degrees. Cosine. Put parentheses around that. Over 1 equals our adjacent, circle, circle, pick it up, x, over hypo, circle, circle, 21. Do not touch a calculator until x is by itself. So we cross multiply. We're going to end up with 21 times cosine 18 degrees equals 1 times x, which is x. Now you may get your calculators out. So you have 21, and this is going to become a decimal, equals x. So I do 18 cosine. I get 0.951, and it rounds to the 4th decimal place. That's going to be 1, 9511. So 0.9511 is going to equal our x. So I take that, I'm going to times by 21, and I get 19.97. Since it rounds up there, you can write it like this. X is approximately, in this case, 2.0. Let's try this one. Again, labeling opposite, adjacent, and hypo. If this is your theta, that means 14 is your opposite. This side would be adjacent. And if there's your right angle, that means our x is our hypo here. So we have our opposite side. That's an O. We want our hypo, which is H. And you ask yourself what goes with OH? OH. You check here. What goes with OH? And it's SO, which is sine of theta. So I write out that equation. Sine theta over 1 equals opposite over hypotenuse. Now I plug everything in. Sine theta, I pick up my theta, I have sine 66 degrees over 1 equals opposite, which is 14 degrees over x. Do not touch a calculator until x is by itself, which x is not. So now we cross multiply, and we're going to end up with sine 66 parentheses times x equals 14. You're not done yet because x is not by itself. To get x by itself, you have sine 66 together divided by sine 66. So x is going to equal 14 divided by whatever the sine of 66 degrees is. So let's figure what's out. Let's see if you did that correctly. So sine of 66 is 0.9135. So I'm going to get my calculator out. I go 14 divided by 0.9135, and I get 15.3. Check your work compared to mine. It is highly important that you memorize this left column. Memorize this acronym of SOH CAH TOA and these three ratios.